And at Aiven, essential part of our platform is working with data streaming and the processing of data streams. And in recent years, we actually noticed a pattern that more and more of our customers are using AI for processing the data. And today, I wanted to talk about one of such scenarios, which I kind of feel somewhat relatable and also quite interesting to discuss, the sentiment analysis and kind of all the practical aspects of sentiment analysis. So during the next 45 minutes, we are going to look at a particular use case where we are going to transform social media records and get some kind of information related to the sentiment. And for the social media, I'm going actually to use Mastodon data. And I don't know, many of you might be still using Twitter, and I'm still using Twitter, like now we call it X. You can grab the data from some other places, but Mastodon is just super convenient, has amazing API to get the streaming data. So I decided to take that one. Kind of also, we all can understand what kind of data can be there. And our goal, kind of for one of those use cases, is to grab the data and then transform it in a way that using a machine learning model, we can analyze the data and get a bit more extra information so that we can then later aggregate the data and kind of also see if there are like correlations between those properties. So we will come to that part eventually, but the pipeline which we are going to build looks like this. So we have the source of data, can be something else in your case instead of Mastodon. Then we grab the data and we pour it into Apache Kafka topic. Then together with Apache Flink job, we transform the data and add extra information with the help of AI model. Which model exactly we will discuss, because there are different options. And to be honest, those options have different strengths and different weaknesses and different hilarious issues you can get, actually. We will see. And once we transform the data, we put it back into Apache Kafka. And I also like OpenSearch for the visualization so that we can easily find those maybe insights in our data. So this is the plan. But before we begin building that pipeline, let's actually talk about sentiment analysis itself. And sentiment analysis, some people call it opinion mining, sentiment mining, subjective analysis, all those terms. I can imagine that many of you here would kind of already imagine what is sentiment analysis. But so that we are on the same page, let's define it. So it's a computational technique which helps us to figure out an emotional tone of a given message. It can be actually a text, can be an image, can be audio, can be video, something produced by a human. So we are analyzing data, we determine the probability, and to be honest here, with sentiment analysis, we usually work with probabilities. Not really like true, like white or black, so it can be like shades of gray, how positive this message or how negative it is. And sentiment analysis techniques, they allow us to automate the data processing and do it at scale, in real time, which is actually very helpful for a number of different use cases. For example, customer service. And I must say, I'm not sure about you, I hate when I am getting messages from automated systems. However, this is one of the use cases where actually the data can be processed by a model, and then, for example, if you have a product, you might want to reply to a very negative message from a customer sooner because they probably experience bigger issue. Then brand monitoring. So if you actually observe what people talk about your brand, and if there is a tendency that people start talking more negative things than positive ones, and kind of like to measure the temperature, so to say. Then also An interesting case is actually tracking the performance of a campaign. If, for example, you work in marketing and you introduce some changes, some campaigns, and then you want to actually see if that campaign is improving the maybe opinion of people about your product, or actually it makes the things worse, so that you can also see what people are talking about it and how positive or negative that sentiment is. Social media monitoring, perception of new products, same. You might want to know if people started talking something negative about it. Emerging trends. So there are a number of different use cases for the sentiment analysis. So now how it works. And there are actually we can split it in two main approaches. So the first one is kind of this linguistic approach via rules, so where we actually define some kind of pattern. So, for example, people use more words like good, happy, and something else, or they use some negative words. And then this approach is quite straightforward to set up and process the data. However, as you can imagine, sometimes when you use even positive words, you can mean something really negative. And a bit later, we will see what are the challenges of sentiment analysis in general, and especially it's applicable for this rule-based approach, which was used in the past quite a lot. Now we are doing better, because now we are like, okay, we have this all AI stuff, so why not apply that one? And actually that gives us higher performance for determining the sentiment of a message. However, data science, of course, has its requirements. We need to have a pre-trained model, some kind of model. We'll later talk which kind of you can use. Also, ideally, and this depends on the area where you are trying to gather that sentiment, if it's kind of like, let's say, here, Mastodon messages, it's one area. Another thing can be that you are actually working with scientific research. And you can imagine the language of those papers is quite different, so you actually need a model which will be able to understand that kind of language. So in general, the data science approach shows better predictions and can really help you even in challenging context. But what kind of challenging context we have, just also for us to understand what things actually difficult for even a model to solve, even like for human as well, probably. So first one is lack of context. Sometimes we get the message or something, and we just, without having more context, it's very difficult to say, is it positive or is it negative, like neutral or something else. Another thing which is quite language related is sarcasm and irony. This is quite a difficult one sometimes to understand, even though models are doing here quite good, sometimes even better than humans. Then negation and multipolarity. So whenever we have a lot of like contradictory stuff within a message, it can be quite difficult to say if it's like positive, negative, or it can be actually several different opinions within one phrase. Idiomatic language, also pretty difficult because it doesn't really mean literal stuff, and all the stuff where we change the meaning of a phrase by just adding an emoji or making some typos in the message. And then, of course, if you are just relying on the that rule-based approach, that's more difficult to catch. So all of these things we are trying, of course, to overcome. And in this particular session, I'm going to talk about, obviously, how we are using AI models for that, because we want to save our time and our energy on solving those issues. And for AI, we do have numerous different options. Option number one, which is boring, quite a good option. We will come back at the end, but I wanted to mention it first. If we use a dedicated model which is particularly trained to detect sentiment analysis. For example, we can go to Hugging Face and then we can search for sentiment analysis models there. Sentiment analysis usually like falls into classification types of models, and then we can, also Hugging Face is amazing if you have never used it. It's a bit of a Python direction, but you can use it to find the models you need. and also you will find a lot of information on which data the model was trained. For example, we can take this Roberta Twitter for sentiment analysis model, and that model actually was particularly fine-tuned to define the sentiment analysis, and we can use it. So this is option number 1. At the end, we are going to come back to this option to see the clarity of approach for that. However, there is another option, and that one actually gets pretty popular. That's why I wanted to cover it first, because it's quite, let's say, it's quite interesting because it's very tempting to apply it. So why not we ask ChatGPT for help? And I mean, ChatGPT is amazing. We are using ChatGPT for all potential questions we have in mind, and ChatGPT never judges for the questions we ask, understands quite nicely all the language, all the weird, even to be honest, when I type something to ChatGPT, I don't even care if I make mistakes or something. So it always understands, super amazing. Obviously, we are going to use GPT model, so we are not going to apply the ChatGPT interface, we are going to use the API instead. And then we have different variations of GPT, of large language model, which we can apply, and it actually gives really good results. It can really tell us or analyze the message quite well to determine all different aspects of that message. And has some other advantages, such as we don't have only to ask for sentiment analysis, we can ask so many other questions about that message, all in one package. So option which we are going to look now, we are going to look what if we apply, I'm using here OpenAI GPT 3.5 Turbo, can be something else. I was processing such a huge amount of data, and that was the cheapest version I could apply. There are other large language models you can use instead, which are very similar. I will discuss those later. So this is the kind of the flow which we will have. Now, streaming data. So as I mentioned, we are going to bring the data from Mastodon or from any source of that messages you want to analyze into Apache Kafka. And I bet if right now, actually let's do it, how many of you have experience working with Apache Kafka? I see, maybe some people are sleeping, that's why they're not raising their hands, but I can imagine that's majority. So I don't have to right now talk a lot what is Apache Kafka, you all know it. So we have a topic, we produce the data, we consume, we do it in an efficient manner where we can produce and consume in parallel, we store data in partitions on brokers. So for this particular case, I was producing data, and I will link everything at the end in one GitHub repository with all the links of the projects in case you want to use that or use it for inspiration. I was grabbing the data from Mastodon using some JavaScript and APIs from Mastodon APIs. And then I was bringing that into a topic, so that I have all data in one place and could see the messages. I was also cleaning up stuff a bit on the fly, but it's not super important. The idea is that for me it was important that I kind of stream all the data from Mastodon into a separate topic, so that then I can use a Flink job to analyze that data. So there we come in to a stream processing with Apache Flink. So now my next question is, how many of you had an opportunity in the past to work with Apache Flink? Okay, I see hands. Here we have kind of a balance. Some people haven't had an opportunity to work with Apache Flink, so I'll stop just for a bit here. So first of all, why stream processing? And we have done for a while batch processing, like Hadoop, and it's quite efficient. However, it's no longer sufficient for the use cases which we are getting in the latest years. because the requirements for latency and real-time can't be really achieved in batch. The use cases which we are talking here about, which are very applicable for using the stream processing, are, for example, detecting fraud and preventing fraud, because detecting fraud we can do actually in batch as well. However, kind of doing the prevention as fast as we can without waiting. So the idea is that we want to stop it before it happens. Same as about spam, and the goal is actually to prevent spam, not only detect post factum, which is kind of easier to do, but prevent is something which we want to do. For this we need in real time analyze data, make some conclusions, and make very, very quick actions. Detecting anomalies, same. So this is where Apache Flink shines. Data quality monitoring, IoT stability, also predicting next user action. And actually, as far as I know, Amazon uses Apache Flink. So I guess this is where when you are shopping for stuff, I don't know, but I can imagine that they are doing their best to prevent and kind of suggest what you need, which you might not know about, and suggest something for you. So this is actually the use cases which we have for real-time data processing. And the thing is, the closer we want to be to real-time, the higher the requirements for the infrastructure that we have. So we need the requirements for fault tolerance, ordering of events, and a lot of different things. And Flink probably not the only tool we can use for the stream processing. However, Flink is one of those technologies which is built on a lot of lessons learned from the previous generations of similar technologies. So Flink is actually quite a powerful tool, which is lovely also to use, even though within it, it's quite complex technology in my opinion. So what Flink allows us? Exactly one, semantics, and I can imagine that a lot of you also Kafka people, we understand the value behind it. Flexible time semantics and kind of the time perceptions, and also the ordering of the events and the rest. Latency, which is quite important, that's the millisecond latency we have. A lot of built-in connectors with Apache Kafka, with Apache Cassandra, DynamoDB, and a lot of other technologies. Also layered API, so that whatever your needs are, you can rely on that with Apache Flink. And finally, it's kind of so Flink was created in Berlin, and I am based in Berlin, in one of the universities. It's used by Alibaba, AWS, eBay, so it's quite a lot of successful stories there. Also to give a bit of kind of understanding to Flink internals without getting too deep, because this is not really very focused on Flink talk. The Flink itself is, the complexity is pretty high when we try to get deeper. The idea behind the Flink that we want to have an execution flow which is very, very efficient, so that when we even executing something, we transform the execution tasks in parallel and we try to make it, let's say, as efficient as possible. We have checkpoints in Apache Flink to make it fault tolerant, so you can enable those if you need them, so that periodically we take persistent snapshots of all the state in every operator, and then in event of a failure we can restore the complete state and resume the processing. And so those checkpoints we kind of take on a regular basis, and it helps us. Also, the stateful stream processing which we have, which means that, so for example, you have an application, you send some input data, and then you have the output data. And meanwhile, you actually store the state, you update the state object. But that state object, you can also access outside of Flink. For example, if you want to have some analytical data processing on top of it. So this is actually quite powerful when you want to have a scenarios where you want actually to have, I don't know, maybe some data warehouse with some persistently stored data, and also on the flight you want to access the real-time changes which are happening from the Flink state. We also can work with time where the events are not ordered one by one. So we are using watermarks to help us to measure the progress in event time in Flink, so that even if you have kind of chaotically arranged events, we can still work with them. So this is kind of like very, very short, like why Flink is amazing, why it's actually also quite complicated within. The Flink application itself, and if you are a Java developer, so Flink application you can write in Java, you can write in Python. As I mentioned, Flink actually like a layered, has a layered API, so you can also perform certain operations within SQL. But here I use some Java. And then we create an environment, we define the source, we define the sink, and then we tell what exactly we want to do with the data. And here I wanted to transform the records. To transform the records, I used an OpenAI model. So, and here is actually like going into that large language magic, GPT magic, what I created, because for working with GPT, with the models such as GPT, we need to create a prompt. And this is actually kind of an advantage of that mode, of that kind of type of working, because we can ask for numerous different things for a model for us to do. However, we need to create a prompt. And if you worked with ChatGPT, you can know that depending on the temperature parameter which we are using, the results actually kind of somewhat unpredictable. The generation is kind of by design done that it actually we don't get the same response all the time. So anyway, so at first I was like, okay, let me create this prompt and ask for most important stuff which I wanted to have. So to analyze the message, to get the sentiment analysis, first of all, but then also to get all the interesting other stuff, like for example, language of the message, if there is a sarcasm in the message, large language models are pretty good with detecting that one, category of that message, also because I wanted to filter out anything which is like offensive, rude, inappropriate. I wanted to filter it out, so kind of to detect that as well. And then I wanted that the model returns me a response well structured so that I can parse it later. Which is kind of like, it's an easy thing to ask, right? I mean, models are so smart, like why can't they do that? So it was not really, let's see how it works. So also for the, when we send the response, the request to OpenAI, we inform what kind of role it has and what exactly our expectations are. So here I said, okay, you are processing the social media content. For the Flink, we combine the jar package, and then the jar package we upload to the Flink application. Here I'm using Aiven for Flink, but you can use whatever Flink implementation you have. And then that kind of worked. And I realized that, okay, so now I have the processed messages, another topic which was created with the help of Apache Flink, and it seems that I'm getting data what I expected, like if I'm looking at least at one record. So I am getting the sentiment, I'm getting the language, if there is a sarcasm, category, and if it's appropriate language. I was like, yeah, it's amazing, like it works, easy. No problems. And then it was, okay, now I'm going to visualize it. So has anyone used OpenSearch in this room? Okay, I see the one hand, Elasticsearch. Everyone, okay. So, you know, OpenSearch is an open source version of Elasticsearch. more story to that, but it's outside of the stock. So OpenSearch has amazing tool as dashboards, which makes it quite easy to combine all things together. And what is amazing with OpenSearch is how easily it is integrated with Apache Kafka. If you have the scenarios where you want to sync the data from Kafka and then to aggregate it, OpenSearch is just amazing because with the Kafka connector, more or less, you actually, with a simple JSON information to access data from Apache Kafka and to put it into OpenSearch, you do it with almost no extra stuff. So with that, I brought the data to OpenSearch, and this is where I started uncovering a problem. I started looking at the records, and I was processing on the flight a lot of data, and there was something like weird, because when I was, for example, looking for appropriate language, I realized the model sometimes, like every now and then, it was returning me, for example, values with some typos. Like, I mean, I also cannot really spell appropriate very easily, but the model I kind of expected that the GPT model should be able to at least like spell things correctly. And then also, of course, punctuations was kind of like here and there. So if I looked then, for example, for the like sentiment analysis, like the whole variation, even if I tell the model, please use these particular words, it's not exactly that the model would follow that. So I'm like, okay, it's natural effect of a GPT model, and it's almost works all the time how I need, with some exceptions. So I started adding and iterating on the prompts, and this is where a lot of people actually do say that the prompt engineering is a thing, so that you need really to know how to work with prompts and how to write the prompts. They're totally right. I'm not even sure that I perfectionized my skills in that, but I tried different things. I realized if I actually repeatedly say, please spell the words correctly, it starts spelling the words somewhat better. So I did several iterations. I tried to narrow so that it only uses certain options and not everything. For example, like for has sarcasm, no sarcasm, so it uses those, or unknown, so it doesn't really try to describe me anything. Also quite important that it actually replies only in that format. And it kind of worked, even though the word appropriate was still an issue. So I don't know, like there is something with that word which I couldn't really solve. But in the end, at least for majority of the cases, I could actually pretty well define and kind of have it reply to me in the format I was expecting. The only thing, for example, for the categories, which I provided it with a list of categories which I wanted to see, the model didn't really care about that at all. But generally, its categories kind of fall on the range which I accepted. It was like normal, so it wasn't so bad. So then, together with OpenSearch, I could visualize this. I could define what correlations we have. For example, if we are looking at the positive, or like here, it's negative messages, majority of them are like news or politics, all that stuff, which is kind of expected, I guess. Then for the negative ones, for the positive ones, it's like technology, sports, entertainment. So yes, then also for the inappropriate language, it was falling into those categories. I dreading to think what is unknown one, but whatever. But yeah, so that's how I could also like to see those correlations. Yeah, so this is actually like this is where the kind of mistakes which with appropriate language, just to screenshot what kind of words it tried to write, and this is where I couldn't really fix it whenever I tried. I tried with GPT model 3.5. Technically, maybe the latest ones would be better. They're more expensive to run, but also as far as I know, then the language-wise, the 3.5 should be quite sufficient for all the needs. It's not about that. But yeah, so this is what if we use the GPT model. However, and this is actually where you will Google, for example, sentiment analysis with OpenAI or sentiment analysis with Llama or all those things. A lot of people, and even like I often see on Reddit, people are discussing how they're using the large language models such as the GPT, Llama, and the rest for sentiment analysis. However, it's not the only option, and I understand the value of it. However, there is a lot of side effects related to the prompt engineering and also to the very creative response from the model. So I wanted to come back to another approach and talk about a different type of model. So here I call it dedicated model. So it's kind of some classification model, which importantly to have here, we want still to have a very smart model. So the models which I was looking at is a transformer model, and here kind of how it can work. Here I'm using the SageMaker. Technically, you can use whatever interface to deploy a model. SageMaker just has a lot of jumpstart models. So I selected just a text classification model, which I found by just typing the sentiment analysis. And the first model, which was the most popular, it suggested was the one which is based on the model which is part of the catalog of the Hugging Face. It's Dilbert-based uncased. This is not the only model which we can use. However, this one is quite interesting. It's also latest generation of the large language model, or let's say if we take the broad definition of a large language model. This is also a large language model. It's a BERT model. So how we can work with it, this is just like a bit of code snippets. Again, all the code samples, the stuff is in GitHub repository, which I will link later. But here we more or less send the request to that model in SageMaker, and then we get the response. And the response now, first of all, we don't really need to provide some kind of prompt and try to convince the model and beg the model to spell stuff properly and give us stuff in a very specific format of the text. It actually always gives us, so here I have the text and kind of response per phrase of text. And it gives us, returns us probabilities, returns us numbers. And as an engineer, I love to work with numbers and not really try to understand what GPT is trying to explain to me. So here, for example, the probabilities, the arrays, the first one is what is the probability that the message is negative. The second one, is it positive? So the first, for example, the message, I'm so excited for the weekend, that's definitely positive. And the other one, for example, it has the number for negativity is pretty high, so the terrible customer service is considered to be negative. So this is kind of the biggest difference in how it returns us the response. But the question is, which case, which model, which we should use, and what is actually the difference? Technically, I mean that both of them return us actually correct information. The GPT model or this kind of generative models, they are very, very smart. We know, we trust them. They're used everywhere right now. But should you actually use it all the time? So let's compare them very briefly, and this is maybe outside of the streaming world, but it's actually quite exciting to know what is happening in the AI world. So I was taking that example as a Dilbert-based uncased. However, if you look what kind of model as the classification model you can use, a transformer model, this is the same, very similar to the Twitter Roberta-based sentiment. And there is a variety of models in that field. If you go to Hugging Face, if you ever use it and you kind of look for sentiment analysis as a keyword, and then you see, and those will have quite a similar thing. They will be all based on the BERT model. And BERT model is a model which was developed by Google and was released, the first version, more or less the same time as a GPT model. But now, like, just to have a very quick comparison, like, so because I mentioned right now DistilBERT and this Twitter Roberta base sentiment, and whenever you looking at those models, which you can use for classification and for sentiment analysis, just that you understand also the differences. For example, DistilBERT is a smaller, more efficient version of BERT. It's actually the one which is super, like, it. When I was looking at the SageMaker, that was the most popular BERT model because it's generic. The Twitter Roberta base sentiment is actually improved version of the BERT models, and also so here it's optimized, and then it's fine-tuned for the base sentiment analysis. So while DistilBERT is a general purpose model, the Twitter Roberta based model is actually designed for sentiment analysis. You can use actually both of them. It's just like DistilBERT you can use also for other cases. This is a screenshot of the research, or research is like a project which tried different models and different approaches for the sentiment analysis and classification, and they found that for the BERT, the probability or the kind of correctness of the prediction was the highest. GPT is not on this list because GPT is kind of, I don't believe that actually they even consider it using that one. So now BERT versus a GPT model, or we can say BERT versus, for example, Llama. Has any one of you used Llama models? If you can raise. Okay, I have, so you know what is Llama. So it's kind of open sourced, not really open source GPT model, but kind of it has very similar architecture as GPT, but it's something which you can run locally on your machine, for example, with Ollama platform. And if you have never heard about Ollama, check it out. It's actually something where you kind of just load the model as you would use with Docker containers. It's super, super convenient. So now comparing the BERT and GPT model, because like both of them can think and give us good prediction on the classification of the data, of if the message is positive or negative. But they actually work very, very differently, even though they're both are transformer-based models. And transformer, we actually hear this a lot. Transformers are super, super powerful. This is something which kind of changed and advanced the whole model performance aspect. However, BERT model, which was developed by Google, also it was like 2018, this is decoder only. So BERT is designed for understanding the language, for natural language understanding, NLU, versus the GPT is the opposite. It encodes the text. It's actually kind of generates the language instead, not understands, but generates it. What is also quite interesting about BERT, it's bidirectional, so it actually looks at the text on the left and on the right and tries to understand and kind of move always to both directions to give a better understanding of the text, because it focuses on the text understanding, versus the GPT is actually only one direction to the right, because it actually tries to predict the next word every time, versus for BERT is like understand text and the context around it. That's actually why also, in my opinion, BERT is smarter in predicting the analysis, because actually it's focused on the understanding, not on the generation of text. And also the difference between like this masked language modeling, so the random words are masked and the model is trained to predict those masked words based on surrounding context. It's for BERT, and GPT uses casual language modeling, where it tries to predict the next word in the sequence, or the next like these characters in the sequence. So that's why, kind of coming to this pros and cons, what should you use? Specialized models or generative language models? And by generative language, I'm talking about here GPT, of course, but also Llama, for example, because I also see a lot of people discussing, like, for example, using Llama models for sentiment analysis. So if you want to have high accuracy in sentiment analysis, because also the BERT models, technically they're often easily fine-tuned. For example, that's why actually a lot of models you can find in Hugging Face related to BERT general architecture, because that was actually open. So GPT doesn't allow us to see a lot of fundamentals about the model and fine-tune that, versus BERT had that. So you actually can either use a fine-tuned model already stored, for example, like if you search for it in Hugging Face, or you can fine-tune on your own. Also, specialized models, if you're talking something like, they're usually smaller. So they usually have only designed for performing one task, instead of, like, for example, GPT can give us all the variety of things. However, running a GPT model is actually, or running a Llama model, it's a constraint in resources, so it requires a lot of power on the machines, versus if you run a specialized model, actually it will require less power. If you don't need some extra powers that LLM offer, for example, like determining the language or determining if it has sarcasm or whatever, then you can actually go with specialized models. It will be just more practical. And of course, the better consistency in the response is so valuable. Versus if you, of course, using the generative language model, such as GPT or Llama, you can apply multiple tasks within one prompt. You can also work in the mixed context and uncommon domains, and you can kind of embrace all of that under umbrella of one model instead of using multiple models for different cases. And the last thing which I would like to leave you with, for specialized models, you can check the Hugging Face. This is the machine learning platform, which is quite practical to search for the models you can run on your own, or actually use the API or deploy it on SageMaker or somewhere else. LangChain is amazing also to run the models, but also if you are using the RAG pattern, for example, LangChain is amazing. How to use it? You can deploy, you can, SageMaker, Hugging Face. If you are working with generative language models, and especially open source, check Llama. Again, LangChain is amazing because here you can combine the embeddings models together with LLM models and have more power with extra context. There is the ways how you can deploy it, of course, like Llama is for open source, and for the rest you can use a lot of different platforms like AWS, Google, Microsoft Azure, and the rest, and then access those models. So which thing to choose for sentiment analysis? I honestly would go with BERT because I think it's predictable, it gives better quality. However, using generative language models actually is widely spread, and there is a lot of applications, and I'm still probably need to grow my love towards that direction, but maybe I'm just more like a BERT person. So that's from my side. So you can find me later together with my team at the booth 303, together with Aiven colleagues, and a couple of links which I would like to leave you with. So first of all, if you are interested to check also the platform which we have with Aiven, because it has the Flink, Kafka, OpenSearch, and actually a number of other technologies under one umbrella where everything is integrated together with all the security and the rest. You can check and get extra credits there. And this is the latest link to the projects which I mentioned, and kind of repositories and code samples. And yeah, so that's it from me. Yeah, thank you.